So we have another math counts problem. So this was national number 22 on the spring test. So we have S as a non-empty set, and P of S is defined to be product of the elements in that set. And what is the sum of the values of P of S over all the non-empty subset of this given set? Okay, so it's a bit complicated looking, but just kind of start with, like, we can say um let's say we choose like two numbers. Let's say 1/3 and 1/4, right? And let's say this is my a subset, right? So one of the subsets. And it says the P of S is defined to be product of the elements in S. So we want to multiply 1/3 and 1/4, so which will give us like 1/12. Okay, so if I have just 1/3 itself, so right, as my subset, so the product will be just 1/3. So if I have like any three, so let's say we have 1/3 times 1/4, 1/5. So you will get like 1/60. And then we just want to see all the possible product of the numbers in this set. So like you can go ahead and try listing and stuff, but it will take a bit longer and tedious, and then you may miss some stuff. So what I will do instead, in a way that like I'm gonna write an expression that will give me actually all the subset product. So one way to think of is this, like we can have 1 plus like 1/3. If I multiply this by 1 plus 1/4, and then 1 plus 1/5, and then 1 plus 1/6. And then you can continue doing this all the way like 1 plus 1/9. And then the last one would be 1 plus 1/10. So like when you multiply these, you actually end up getting everything that you are looking for. Because if you just imagine like when you multiply 1 by 1 and then 1/5, you just get 1/5, which is going to be one of the subset, which is just one element in it. If I multiply 1 by 1/4 by 1/5, you get another subset that is like combined with 1/4 and 1/5. But every time you do this multiplication, you end up getting a different subset, a different unique subset, which is like we sometimes find a like counting in different ways that is kind of easier to count, but that will give us the same thing as what we are trying to count. And then we call this kind of stuff bijection or one-to-one correspondence at some point. So this is actually a good example of kind of introducing that idea, even though we don't really kind of need any concept-wise stuff in this problem. But since this is a question was given, right, on the national test, even though they don't really kind of tell us that needs to be used one-to-one correspondence or bijection idea and stuff. So maybe it's good to dive into those topics and get better, because this is just one problem now. Then maybe next year's it will be something a bit different by using the same background. So that is good to review bijection and one-to-one correspondence anyway. And so if I multiply all these, that's what I'm going to try to find. But at the same time, if I multiply all these ones, which give us like a 1, right? Which is going to be like 1 plus a bunch of other terms. But everything other than 1 is actually what we are trying to add up, right? So that means if I want to find this product and subtract 1 from my product, then I will get my answer. So, but at the same time, this is really nice because there's a nice telescoping going on. So this would be just a 4/3, and then 5/4, and then 6/5, and then 7/6. You can continue all the way 10/9, and then 11/10, right? So cancel these guys, And then these will cancel, these will cancel. So you got 11 over 3. But this is the sum of everything plus 1. 1 is not a part of our product in this subset multiplication, so we should subtract that. So the P of S would be just 11/3 minus 1, which is going to be 8/3. So that should be our answer. So it was like interesting question for sure. So that was number 22. But I'm gonna just add some stuff in the chat, I mean in the description about the bijection and one-to-one correspondence. So if you kind of want more stuff about those, so you can always review and get better on those. Anyway, so I'll see you in the next video.